Good morning, everyone, and thanks for taking part in this meeting organized by UNESID about one of the hottest topics for the iron and steel industry on its way to climate neutrality, which is the use of hydrogen. The companies that form UNESID already expressed their commitment with the fight against climate change when in November 2019, almost 2 years ago now, they pledged to transform their industrial operations to reach climate neutrality before 2090. With this commitment, our industry responded to the social demand which was already expressed in the Paris Agreement and the Sustainable Development Goals from the United Nations. Our companies are working in the search for solutions that let us reach such climate neutrality goal while keeping a sustainable business model. An industrial transition which is convenient both for the development of digitalization and for progress in environmental solutions applied with sustainability criteria. This commitment means the search for alternatives, which let us rethink the current productive processes. We work in modifying the processes and the energy vectors which are in use now. Hydrogen is and will be a line of work which is going to keep us busy in the next years, no matter what colors are used to name the different variations of hydrogen. In UNESID, we know that in order to tackle the transition to decarbonisation, a deep industrial transition will be needed. This transition requires availability of large amounts of low-carbon energy, a development of the implementation of new processing technologies, a legal framework to provide legal safety and certitude to companies, and definitely a final price of energy which is competitive, stable and predictable. The efforts that are being made in Europe and other areas are focusing mainly on the production of low-carbon energy vectors. In a second and lower degree, they are focusing on the availability of technology that makes its use possible. In a third level, on the transportation of those vectors from the places of production to the places of consumption. Therefore, we consider it essential to sketch the value chain of renewable energies in general, and hydrogen as a European and Spanish bet in particular, upstream, but keeping an eye on a crucial part, which is downstream, transportation, storage and consumption. All of this needs to be based on a solid legal framework which generates a safe collaboration environment for all the players, from the generators to the final consumers, and including resellers and companies in charge of transportation and storage. UNESID considers it mandatory to ensure a sustainable demand for the hydrogen producers, to ease the growth of intelligent development and distribution networks for the transporters, and also a stable supply for the industrial consumers to operate and compete in the international markets. We have to remember that if the total substitution of natural gas by hydrogen is accomplished, the need for hydrogen in the iron and steel industry will be very important. Along with the efforts we are already making in investigation, development and innovation, we'll need a sufficient and stable hydrogen supply in our factories. Only when a stable supply can be guaranteed at a sustainable price, we will be able to guarantee the production of low-carbon steel. There's an investment to be made in order to make this possible, the transition to renewable vectors as hydrogen. All the parts involved will have to make important investments. We consider that with regard to deploying the government's agenda on hydrogen, the public income support must be oriented to the previously mentioned stages. Without a storage and transportation structure, without teams that are capable of using hydrogen in the industry in a safe way, and without a human capital which has been properly trained and prepared to manipulate such installations, a real transition won't be viable. The public support from the state cannot be focused only in certain stages. In this, as in many other aspects, an integral vision is needed in order to be able to make a decarbonized industry come true. The conference we organized today intends to analyze the more relevant aspects to consider in the application of hydrogen in the industrial activity, in all the phases of hydrogen's value chain, with speakers from hydrogen-generating companies, from companies in charge of its transportation, also consumers of this fuel, and the public administration. We are very grateful to have with us in this meeting some high-profile speakers, which are going to present the driving forces and barriers that surround hydrogen as an energy vector, key in the decarbonization process the industry has to undergo, taking into account the role that steel itself can have in the so-called hydrogen economy. And with no further delay, I repeat my gratitude to the speakers for accepting to share their knowledge this morning with us, and all of you for your participation in this act, which I trust to be very beneficial to all of us. Thank you very much. Thank you very much for your words, President, and thank you very much to all of you who have connected to this meeting we organized from UNESID, and which we're sure won't be the last one dedicated to the relationship between hydrogen and the iron and steel industry. Our team has intensively worked in the organization of this event, and the amount of attendees confirms to us the interest that this energy vector generates in our industry. I know we are all tired of screens, but even though the next meetings are taking place in a hybrid format, when we decided to organize this one, we didn't have any visibility of the development that the fight against the pandemic was going to have yet. As any technological novelty, the introduction of hydrogen will require not only substantial investments, as our president said, but also significant changes in the development of operations. The participation of everyone will also be necessary, and I want to highlight this. That's why I want to thank especially the presence of the union representatives that are with us today. The legal framework is crucial to carry an organized development of this new technology and give legal safety to investors. We need a non-directive regulation, and we need it not to be neutral with regards to the several alternatives of the development of technology. We are very aware that we are in a race with other countries, not only in the European Union, but also from outside the Union, and to become laggards is not acceptable. I don't want to spend more time, but give way to the true leading roles of this conference, the speakers, to which I reiterate our appreciation for accepting to share their knowledge of the different features that take part in hydrogen's development with us. And with no further delay, I give the floor to Alejandro Cros, General Subdirector for Sectorial and Industrial Politics of the Ministry of Industry, Tourism and Commerce, which accepted to moderate this meeting. Alejandro, the microphone and the screen are yours. Thanks, Andres. Good morning, everyone. First of all, thanks for the invitation to moderate this roundtable of the iron and steel industry and hydrogen in the future of this sector. Thanks for inviting the Ministry of Industry to have the opportunity to participate by moderating this table. As you know, the Ministry has been trying for a few years to do its part to impulse hydrogen as an energy vector, because it means not only helping in the challenge of decarbonization the industrial sectors face in the new years, but also the chance to have a new industrial sector which can be very relevant. It's also necessary trying to impulse and create the industrial network associated to it. We are currently collaborating closely with the Ministry of Transition. We also have one of its members today as a speaker. It can be both for helping Spanish companies going for the European CPI subsidy program, so they can carry out their strategic projects, and collaborating in the different aspects related to the implementation of restructuring mechanism funds and the future subsidy calls that can take place from the Ministry, from the IDAE entity. And it's an honor to moderate this roundtable as well, as Bernardo said, because of the great status of the speakers, which are very representative of each of the links of the companies they belong to, or of the involved administration.
Encantado de estar esta mañana con todos ustedes. Recordarles solamente
I'm glad to be this morning with all of you. I just want to remind the speakers we only have about 15 minutes for their speeches. It's sort of flexible, but please try to accommodate to that time. I also want to remind the attendees, I think we had over 200 attendees, so that everyone has an idea of the interest we'll have on this matter, as it has been previously pointed out.
I'll remind you that you can try to start thinking about your questions through the chat, because we will write them down. And at the end, we will have about 20-30 minutes to channel these questions to the corresponding speakers. We will try to select those that are more general, if there are too many, and you can write the questions from now on. As Andres was saying, I won't waste more time because we're interested in the speakers and what they have to tell us. First of all, we have Teresa Resino. She holds a degree in industrial engineering from the Polytechnic University of Madrid. She also holds an executive MBA from the Instituto de España en PADE from ESA Business School. She began her career at the Madrid Development Institute, then moved to the energy sector, working for Gas Natural, until she joined, finally, the Air Liquide Group, where she has held positions of increasing responsibility in many different areas. She is currently president of Air Liquide Spain and assessor of the subsidiaries in Iberia in industrial and medicinal activities. She has been president of AEGE. And now she's the company's representative in the most relevant associations in her sector in Spain and Portugal. And she is chairwoman of the Energy Environment Commission of the Círculo de Empresarios. Teresa, if you're ready, whenever you want, you can share, please, the presentation. Perfect. Thank you so much, Alejandro. Thank you so much to UNESID, Bernardo, Andres, for inviting me. I'm so sorry for my voice. I'm sure that it wasn't a partying week. I just didn't stop talking this week, because those who know me know that I'm in love with energy, the industry, energy transition, and of course of hydrogen. Thank you so much to you, Alejandro, because as Andres was saying, you are a friend of steelworking. You're a friend and a collaborator in the industry as a whole here in this country. We have a lot to thank you for. I don't know if you can see my screen already. I hope so. There, we can see it. Thank you. Perfect. Thank you so much, Alejandro. All right, a brief presentation. The group Air Liquide is a group that existed for 100 years already. Over 64,500 employees. And we share a common ambition, which is being leaders in technology and service for industry, but especially a strong engagement with our clients to contribute to sustainability. And clearly the energy transition is a priority to us. Please allow me to say that we are veterans in hydrogen, not so much in renewable hydrogen, of course, but concerning hydrogen, we are throughout the whole production chain. We are present here with over 2 billion sales a year, 50 plants in hydrogen production, 300 plants, of which 400 are already, 40 already in operation. We're present in many market segments. If we talk about steel making, I won't be talking about the methods and technologies that are alternatives that we have for carbon reduction. I think that steel making in this country has renewed its engagement for several free years with the energy transition. As Bernardo was saying, and Andres as well, we are facing a new challenge with hydrogen and renewable hydrogen and how they can help with the decarbonization in steelmaking. Here, if you'll allow me to simplify, I'm sure that many listeners to this webinar know this much better than me, but there are three alternatives that are very clear for steel with a low carbon content, which is putting hydrogen in DRI. We're speaking about several tons to get 80% of reduction in emissions. We can also have hydrogen injection and blast furnace. We're talking about several kilos for a reduction in 20%, 40, 50. And of course, all the processes of carbon capture or sequestration and capture and use as well. Water's down here. As I said, it's nothing new for you, but I'd like to share with you. We participate in hydrogen Causfield that has been created for several years. When speaking of hydrogen, was speaking about science fiction almost. And one of the last updates concerning hydrogen on hydrogen perspectives mention 2050, which could be a reduction here of 18% of final energy demand. This is the missing piece in this mission to decarbonize our economy and our production systems, because it may represent up to 6 gigatons a year of CO2 emissions. This is also going to create an important change in terms of sales. As Bernardo was correctly saying, the importance and development of the hydrogen has to be in all the chain links. The ecosystem of hydrogen that we may be able among all must be strengthening us all, the production, transportation, and of course, application, because no doubt, if we don't have elements to drive demand, the chain won't be developed. The hydrogen low in carbon, here we talk about electrolysis often, but we think, and it is in line with the strategy of the European Union, that electrolysis created with renewable electricity, but also hydrogen produced with biomethane, are ways of getting this renewable hydrogen that we want for decarbonizing industry processes. And we think that storage, carbon capture, or storage and use have a lot to say in this process, as we are seeing already in very important projects, especially in the north of Europe and also in the United States. The uses of hydrogen. There's clearly an industry, that is now consuming hydrogen. And so the substitution of the hydrogen, what we now call this gray hydrogen, and we need to, there's clearly a lot of applications here for steelmaking. The value chain of biomethane seems specifically important because it drives a new ecosystem, an ecosystem that will contribute also to highlight the zones or the areas that in Spain and many other countries in Europe and in the world are suffering a depopulation. We think it is a chain that needs to be strengthened, and then we can get an ecosystem in these areas. And at the same time, they can get to the energy transition we are seeking. The production of biomethane, as you know, starts from hydrogas. Then it goes to biomethane. And one of the advantages is that this may allow to use assets that currently exist already. I won't talk about technical topics, to not bore you. And I'm not the great expert here in the house. In terms of production, the most important topic is hydrolysis techniques. We'll see later on which kind of electrolysis exists, because not all are the same, but we can talk about a consumption of 60 kilowatts per hour on average. We're talking about water here, 2.5 kilos of water for production of hydrogen, one dedicated to the process, and another kilo or kilo and a half that is good for refrigeration, that is recovered. We're talking about hydrogen productions that, well, it depends if we're talking about cubic meter an hour or not. But to give you a rough idea, one plant of electrolysis of 1 megawatt is going to produce 150 tons per year. As I was saying before, we have different technologies of electrolysis that are in several levels here of maturity. Bernardo was talking about this before. The production is going to continue developing. We're talking mainly now of 3 technologies or 4. Within the alkaline, we can differentiate the atmospheric and pressurized one. The conventional one was developed first. There's an advantage. It doesn't need noble metals, but there is disadvantages. There's low current and the time of response is high. This means that for feeding that is 100% renewable, it has major complications. Bernardo was saying, and also Andres before, I'm sure we will talk about hydrogen still. I think we hear about hydrogen every single day, the projects every single day, but it is a technology that is in development. It's a technology that we have been working on for years, but we're seeing how it's accelerating. The atmospheric alkaline here on the left, alkaline pressurized here, is obtained at a pressure that is more appropriate for our industrial processes, waters down. And then there's also the PEM, the membrane of proton interchange. And here, the hydrogen is very heavy. It's pressurized directly, and we get a quick response. However, it needs noble metals and titanium. Without talking about a lot of technical aspects, there's a third or fourth, which is soy technology, that is electrolysis of solid oxide. This technology isn't being marketed yet. It needs very high temperatures. It can be worked at a high pressure. It is reversible. It has a very high efficiency, but of course, the temperature it needs to be worked in is a big disadvantage, and it's very expensive. Different players are researching it. So that you have a rough idea here, the CapEx values currently are quite extensive. But there's clearly a learning curve. If you allow me to speak of our experience, in 2017, we had electrolyzers throughout the world for different applications in the industry. You can see in the context, compared to other kinds of plants, it's kind of little, but it's important for what existed at that time. But in 2017, there were the biggest electrolyzer working only had 1.25 megawatts. However, 2 years later, we launched in Canada, truly at beginning of 2020 in Canada, the biggest projects in the world. And now we are advertising very important projects in a bigger size. We published last week the expansion of a project that we have in Normandy that will represent 200 megawatts. And we hope to produce 30,000 tons of hydrogen a year. In this image, we need to see this production of hydrogen and which costs it has. The production of gray hydrogen, currently we're talking about between 1 and 2 euros per kilo. If we are talking about green renewable hydrogen, being by electrolysis or biomethane, the biomethane is a little cheaper right now. We're rounding 3.5 to 6 euros. So the range is quite high. It's clear we need a development, just as renewable energies, wind energy, etc. We need a technological development, but also, as you were saying before, we need support from administrations to be able to accelerate this trend. We hope that by 2030, without any additional support, hydrogen will start to be truly competitive. And in the meantime, to get there and to be able to accelerate the learning curve that we all need, we need this and the support. But I completely agree with Bernardo. It's a support not only in production, but throughout the entire chain and to demand, of course. Okay, why do we see a reduction in 60%? 60% is what we're already seeing. So we're sure that with an acceleration like we're seeing in projects throughout the world, but also in Europe, and we hope that in Spain, undoubtedly, we will manage this reduction. It will come with the capex reduction, clearly. Of course, with some scale economy, it's not the same to have an electrolyzer of 2 megawatts than 200, of course. We need to take into account the learning curve, the logic, and also energy costs. This is a main topic here. Without electrical energy, as Bernardo was saying, that is competitive and with a stable, predictable price, it's very complicated to drive this renewable energy projects. But undoubtedly, we are working with renewable sources. We're talking here in particular about forecasting fed by Ionic offshore. We're starting to see a price range that puts us here at the values of the start of 2021. This is the possible evolution costs of production following the electrolysis technologies. Without getting into detail, I also don't want to say what is the technology that will be the queen here. We need a solid expertise to see the needs of the client concerning his supply, if he can produce with a continuous process. What's clear is that we will have a strong reduction in cost. And for this, as Andres was saying, we need to accelerate the learning curve. Because if we do not, it's going to be very complicated to get to 2030 as we all want. Speaking about the decarbonization process, we need to take into account that in our case, in particular in the steel industry, we have worked a lot in reducing CO2 emissions, but there's a great technological challenge towards decarbonization, in which hydrogen will be a key element. And of course, the carbon capture techniques. But I liked hearing Bernardo and Andres a lot. because you talked about a topic that we all need to realize important investments, and we need to learn to be able to accelerate the learning curve. This is why we need partnerships to develop these technologies and make them economically viable. We need a legal framework, a sustainable one, and support measures. We're seeing with a lot of satisfaction how Europe is putting things on the front lines, is supporting investments. In Spain, we have a lot of expectations, high expectations, and I'm sure that everything that our colleagues are able to tell us will be extremely interesting. We must not forget, as Bernardo was saying, the need of having contracts per difference, like in Portugal. 4 or 5 weeks ago, they drew a draft of these kinds of contracts, but for the Portuguese industry in terms of hydrogen, it's especially important. We need to look at the indifference prices compared to other technologies. We need a hydrogen price, tell me if I'm wrong, but is in a range from 1 to 2.5, where we're talking about raw materials. We're talking about €1.50 per kilo. So there is a learning curve, but especially we need to select the projects that may make this learning curve have a more expensive impact on this organization. And of course, with a client or industrialist that is engaged here. We have been working in the last draft concerning this. There's also systems of guarantee of origin that we need to work on. And I repeat, no doubt there are other roadmaps here for the production of energy and renewable hydrogen that is in line with the European strategy of hydrogen. Okay, so I'll stop here, Alejandro. I'd be delighted if there's questions later on. I had included a few examples in terms of decarbonization, but I think that during the chat, we'll be able to mention them. Alejandro? Just tell me concerning time.
Yes, we're going to leave it here. Thank you very much for your presentation. For this review on the different ways of generating energies, electrolysis, for example, and explaining to us the prices and the costs. I think you explained very well the global situation, and this was very useful. Now, without further ado, we have Jesus Gil. He's Director of Renewable Gases in ENAGAS. He's a mechanical engineer from the Polytechnic University of Madrid and industrial organization engineer from the European University of Madrid. He has a master's degree in project and engineering company management from the Energy Business School of Madrid. He has an executive MBA from the IESE, University of Navarra, and he joined ENAGAS in 1998, and since then he has held various positions of responsibility and leadership within the company. He's currently leading the Renewable Gases Department within the General Directorate of Renewable Gases and Services, promoting and developing various projects such as new key solutions for the energy transition. In 2015, by the way, he won the entrepreneurship program of ENAGAS, and he founded a startup specializing in new applications for the oil and gas industry. And before sharing the presentation, could you please share your screen? Because you're all asking us whether we are going to share the presentations and if they're going to be available on the website. So the answer is yes. We will upload the presentations and you will be able to download them in a couple of days, maybe, from the UNESID website. So the floor is yours. Good morning to all of you. Thank you very much, Alejandro. The truth is, when you tell what I've been doing in my life, I realize that I've had a lot of action in my life. And in Enagas, I have always been connected to the new opportunities and new developments. What are the applications of the green hydrogen in the iron and steel industry? Because this is today's topic for us. Well, I have prepared a presentation. Teresa has explained a little bit of what I was going to tell, and please allow me to divide this into 3 blocks. First, I'm going to describe our company, Enagas. And I think you all know this company, so I'm going to be quicker. And then a second block in which I will speak about how the hydrogen can play an important role in the decarbonisation for iron and steel industry. And the third block, which is crucial for a company like Enagas, and is how a company that promotes infrastructure and transport of energy can contribute to the development of this green energy, and so that this energy can reach the end users, which is today's objective. So, quickly now, we, as you might know, we are the technical managers of the electrical grid, and we are CO certified by the European Union. The first infrastructure that we implemented in Spain for natural gas was the terminal of Barcelona more than 50 years ago. So as you can see, Enagas is a company that has been here for more than 50 years, and we've always focused on energy, and we've always been the biggest logistics company that we have here in our country according to the volume of energy that we handle per year. I think that you're not sharing your screen, maybe. You're not sharing your presentation, maybe we cannot see it. I'm sorry about that. Can you see it now? Yes, now we do see it. Thank you. Sorry about that.
Vale. ¿La veis bien, no?
Can you see it now? Yes. Maybe you can press on full screen view if you wish. It doesn't really matter because we are seeing it anyway. I'm gonna leave it as it is because otherwise we're going to waste a lot of time. So I was commenting on who we were. Our company has an experience of 50 years, TSO, independent TSO in Spain and the European Union. So where are we? We were born, of course, in Spain. We have more than 11,000 kilometers of pipelines, 6 plants, and 3 underground storage areas. We are present in Europe through the Trans-Adriatic Pipeline program. We are present in Greece, Albania, and Italy. And in America, we are also present in the US, in Mexico, Peru, and Chile. Our main assets are the transport of natural gas, storing of natural gas, and the management of liquefied gas. We have over 50 concrete projects of energy efficiency, and the main goal that that was set by our managers and set by our president was to be carbon neutral by 2040. So we have advanced our decarbonisation objectives in 10 years, and we're going to base in energy efficiency, culture, within the structure of the company, and the role of natural gas and renewable gases in the future energy model. We're going to go into detail now on the second block, which are the renewable gases. There are crucial energy vectors in the energy transition, and in this sense, in 2019, Enagas carried out a strategic program that was consolidated because we created Enagas renewable Enagas that has all of the developments of the future projects based on two pillars or two vectors: green hydrogen and biomethane. So these are two crucial objectives that we have set. We want to be technology neutral, because we will be able to decarbonize all of the sectors and domains. And we're going to make the most of the existing pipelines, because we know that this is crucial so that we can move forward when it comes to deploying these vectors at a low cost. What are our main criteria to foster our projects for renewable gases? We have 5 main criteria. First, they have to contribute to the decarbonization, and we have to optimize their costs by going towards a fair and inclusive transition. Then they have to be driving forces in the value chain. They have to generate sustainable jobs, and we are also working so that these projects are done with partners. As you can see, we have more than 30 hydrogen-related projects, more than 20 biomethane projects in Spain, and we have over 50 partners in Spain. Now, globally speaking, here you can see a picture of the different proposals done by the different countries, not only within the EU, but also with a global vision worldwide. As you can know, in Spain, we have a roadmap that sets these objectives that you can see here. In 2024, we have to have 600 gigawatts of electrolyzers, and by 2030, we should have 40 gigawatts, and that will be 10% of what the EU has set by 2030. These could be applied for vehicles, buses, and essentially for this roadmap, because we will reduce by 20% the current consumption of hydrogen, of grey hydrogen, which actually now is considered to consume between 500,000 and 600,000 tons per year. So now within the green hydrogen, we work on 4 different assets or points. First, we're going to develop our own technology with research and development projects. In my opinion, we have to speak about many things here. And we also have to work on the pillar of the development of technology and research and development. And why is that? Because it's not only about infrastructure. At the end of the day, and if you do not have the backbone, the research and the development, it will be really complicated for you to have and to reach this learning curve. In this sense, from Enagas, we are fostering projects based in Spain together with other partners that will give us some hydrogen process that will be much more efficient than the ones that we have now. And we know that we're talking about commodities. They are electrolyzers, regardless of what the technology is. And we also want to reduce the cost. And we do have some alternatives that we think can be much more efficient than the usage of electrolyzers. And we have to take it into account what the Spanish reality is, because we have to, we know that Spain has got wind and has got sun, so we have to make the most out of this, and we will look for technologies that will make it easier so that we will not lose efficiency. This is what we are developing now. With Repsol, we're developing some projects. We're also developing projects like, for example, a complete value chain project, or Green Highland in Palma de Mallorca. As you know, it's a hydrogen valley that's been developed in the Balearic Islands. And yesterday, or the day before yesterday, the President of the European Commission, Ursula von der Leyen, set this as a great example for Europe and as a role model for the rest of the European regions. We're also developing projects for the decarbonization of the different economic sectors.
Hacer un estudio de adaptación y desarrollo de esa futura red de...
We are carrying out an analysis or assessment of development so that we can improve our processes in Europe. We have over 30 projects with 50 different partners. I'm not going to go into detail now, but I would like to give you 3 key points. First, they are all aligned with the roadmap of the renewable hydrogen that we have here in Spain. And this is, we focus more on the substitution of grey hydrogen for green hydrogen, and we would like to introduce more renewable renewable energies, and we would like to merge some of these technologies. We are members of the Spanish Association for Hydrogen, of the European Association of Hydrogen, and of the European Clean Hydrogen Alliance. And we are in charge of the transmission and distribution of hydrogen at a European level. So you have 5 minutes at the maximum, Jesus. Okay, perfect. Anyway, Teresa has been talking about that before in her previous presentation, and that's why I'm not going to go into detail now, because it's clear that the usage of hydrogen fits within the reduction of CO2 in the steel industry. However, I would like to say that within the steel sector, we have 2 techniques or 2 technologies that are on the table. We have the smart carbon use and the carbon direct avoidance, in which we would be using green hydrogen as the main agent. So within the expectations of steel production in the European Union, we have an estimated production of 0.5 increase in the production, as you can see, and from 2030 or 2025, we would be starting to use the new technologies that are the new breakthrough technologies, and hydrogen here will be one of the main assets that we should develop. You cannot lie and wait for things to happen. You cannot do that, and this is why we're working. So from a low or carbon neutral industry, we have made a great effort from the 60s actually to reduce the emissions. But if you want to reduce by 2050 between 80 and 95% of our emissions, here you have different alternatives so that we can really reduce our emissions to these high percentages of carbon reduction. And this is why I think that hydrogen-related technologies will play an important role. And the earlier we can do this, the better. And that means also new technological deployments in our infrastructure. So what sectors are key here? As you can see, we have 2 main key points that will play an important role in the reduction of the emissions in the steel industry. I would say actually in all of the production industry. First, we have the energy cost, as you can see here, because we're going to use hydrogen as a producing element. So if the megawatt hour costs 40 euros, or if it costs much more than that, it will change. And we also have to take into account the price of the carbon tones. So how can the natural gas grid contribute to this process? Well, here we have the Climate and Energy Integrated Spanish Plan. And you can see that this plan, the PNIEC, will take into account the difference between offer and demand. and we should try to increase the interconnections with Europe by 15%, and that would mean 39 terawatts of import and export of energy. What I want to say by that is that this surplus of energy, this management of energy, this storing of power and energy might be necessary to precisely manage the high volumes of terawatts that we have, and we will require and need important energy vectors so that we can efficiently manage the electric infrastructure. And in this case, the pipelines and the gas will play a crucial role. What's the role again of the hydrogen? Well, first, we have to make the most of the existing infrastructure. We have to connect regions, store surpluses, make the most of infrastructure, couple energy grids, because hydrogen allows us to actually give some hydrogen to other industries, and this is important. Well, in my opinion, the footnote on this slide is really important. As you can see here, it's 10 times, well, as you can read here, for example, this transmits 10 times the energy at 1 height, and if we have to develop new pipelines, that could be crucial for us. So as we have said, we have the possibility to inject some hydrogen in the natural gas grid, and for us this is really important, and this is a means for us to step by step give this hydrogen to the end users. And this is why the green certificates must play an important role to guarantee the traceability of this energy. So within this Hydrogen Act, you can see the deployment of the hydrogen infrastructures, and you can see what the perspectives are for 2020, 2025, and 2050. And at the end of the day, we will require logistics infrastructures and pipelines that are of the same size that the ones that we have now for gas. And in a certain way, we actually committed to the European Hydrogen Backbone Program, and we are working with 12 different countries, and we will be able to connect production points and consumption points with really efficient logistics. Here you can see the estimated cost and the impact of logistics in the end hydrogen consumption will be really reduced compared to 2040 if we deploy it in an efficient way in Europe. So what do we need to have such a grid? Well, we have 4 or 5 key aspects. We have to develop a legal framework to classify properly the green hydrogen, and then, for example, we will set what the consideration of these green hydrogen will be, and the different legal procedures that we will use on how to maybe change the status of the hydrogen. This might change every month or not, but we have to know that hydrogen has to be really competitive from an infrastructure point of view or transport point of view. We have to give a little bit of context here, and we have to adapt, in this case, the regulations, and we cannot know that hydrogen is a combustible gas, so we have to adapt the regulation to the other fuels and combustible gases that we have now, so that the regulation is adapted to the hydrogen, or maybe adapt the best practices. And here we can take the example from the American regulation. We have, for example, the Contamination Integrated Control and Prevention Act, and this is really important for the electrolysis plant, and we have to review it because as for now they are considered as chemical plants, But all in all, for electrolysis, we are going to, there is water coming in and there is electricity going out, that's it. But if it's under another type of regulation, it might complicate the process of generating new energy. If actually we have these new infrastructure regulation, we have to have a special taxing method at the beginning at least, and then the market of the hydrogen should be organized, and this is really important. And we should have a technical manager of the hydrogen system. And then, I'm sorry, we have to finish. Yes, and then I would like to underline the need to have a competitive fee for hydrogen so that we can reduce the costs of hydrogen production, so that we can really be competitive. So you will have access to these presentations. I have added some annexes, some European projects that we have, for example, like the European the hybrid, and that's everything from my side, Alejandro. I'm really sorry for the interruptions, but we needed to end. Well, your presentation was more than relevant, and the message that you conveyed of the role of your company is really important to foster new projects for pilot projects or research and development. The work that you've done is really important, really relevant, because you taught us on how to improve the infrastructure. Your messages were really important. Well, now, without further ado, please switch off your microphones if you're not speaking. So now we will give the floor to the third speaker. He's Manuel Garcia. He's Director General of Energy Policy and Mines in the Ministry of Ecological Transition and Demographic Challenge. He's an industrial engineer from ICAI, specializing in electricity, and he holds a master's in public administration from the Harvard Kennedy School of Government. And he has been a member of the State Corps of Industrial Engineers since 2005. In the private sector, he has worked in engineering and consulting firms, and in the administration, he has held various positions as technical advisor, the consultant, director of the cabinet in the Secretary of State for Energy, Deputy Technical Secretary General of the Ministry of Industry, Energy and Tourism, and Deputy Director General of Electrical Energy in the Ministry of Ecological Transition and Demographic Challenge. He has also been a member of the board of directors of several public entities and companies such as IDAI, Cores, DDI, Aquanor, CPDs, and NRESA, and as well as the member of the board of trustees of the School of Industrial Organization and the leading brands firm. So, Manuel, you can start. Thank you.
Muy buenos días. Espero que se me vea y escuche bien.
Good morning, everyone. Can you hear me? I hope you can see my presentation. Yeah, we can see it clearly. Thank you. Thank you very much, Alejandro, for introducing myself. Thank you very much to UNESID for having invited me. Thank you to the ministry, because I'm honored to be participating in these important and necessary seminar and conference. So thank you once again for giving us the opportunity to convey the voice and the side of the government on the development of hydrogen in Spain and the new opportunities that we have in our country, because hydrogen, as you have said during the last interventions, is much more than a mere raw material, as we have said. It's an energetic vector, and as such, it gives a lot of flexibility and versatility to the energy sector. And it can have a really important role to complete the last pieces of the jigsaw that we are missing, so that hydrogen is a reality in the future. And as a society and as a continent and as the union that we are in, the European Union, we have to commit to that. Well, first, I want to give you an overview of the European context. And it's true that my colleague just said some of what I was going to say now, but anyway, I wanted to give you an overview on the politics and the policies of the hydrogen regarding the Spanish and European context. Then we have the hydrogen roadmap, which is a bet for renewable energies. In Spain, we talk about renewable hydrogen. You can see that this is the green color. And we like this color, we like green, because this is the option that will allow to be more efficient in Spain as a country. And then we will tackle on the more important aspects that we have identified in this roadmap for the development of hydrogen. And I will tell you what are the different specifications for this steel sector. And then, last but not least, because we don't have much time, I'm going to talk about the resilience, transformation, and recovery plan that we have. As I was saying, in the Spanish context, we have, as we call it, an umbrella, and we have the Climate and Energy Integrated National Plan. Well, and now every member state has to have one. And for the first time, we have included the planification and the energy, renewable energies, because sometimes if we speak about climate change or energy transition is kind of the same sometimes, because we know that these climate change generates 80% of the greenhouse gases. So we have to merge both capacities and both legal frameworks. Actually, we have one measure of promotion, Article 12 of promotion of renewable gases, that will increase the production of renewable gases and energies. Then we also have the PNIEC, which is this Climate and Energy Plan. We also have the Climate Change and Energy Transition Act, as we are saying. And here we have a specific article, Article 12, that tells you literally that the government will foster, through the approval of specific plans, the presence of renewable gases. And we prioritize those raw materials that come from renewable origins. And then here we will also speak about the circular economy that is very much related to the roadmap that we have in the biogas. We are actually doing a draft, and it will be in no time approved by the government. We also have the European hydrogen strategy that's aligned with the Spanish strategy, and this is essential to reach the goal of climate neutrality by 2025. It's important that both in Europe and Spain we have a long-term objective, so that Europe and Spain are actually based on a carbon neutral economy, and we want to reduce actually these gases. So we have these national and European strategies, and with the new Commission, the Commission and Ursula von der Leyen, you know that we have this legal framework, which is Fit for 55, and we want with this to integrate the different changes of renewable energies and to increase from the 45% to 55% these energies that comes from renewable sources. So this is why the renewable energies are being reviewed, And all of these different instruments for the Fit for 55 are really relevant for the industry and for the steel industry, not only for the hydrogen, but for all of them. And the reviewing of these renewable energies is really important. And as Jesus Gil was saying before, we have to take the first steps towards the creation of a market, a European hydrogen market, so that the funding of the hydrogen is well done. And we have to be aligned with the decarbonisation process, and also when it comes to alternative infrastructures. And Alejandro Cross actually is very much committed to that. And this, again, is very much related to the use of hydrogen and the transport of the very same raw material.
The roadmap of hydrogen in Spain is a bet for energy, renewable energy. It establishes that hydrogen is a sustainable solution for decarbonization. It's paramount due to its industrial aspect, the capacity of developing innovative value chains. We are facing a revolution of renovation in several levels that comes from the energy sector, but at the end of the day, it has repercussions in practically all the scopes of the economy and society. And why hydrogen? Well, because with technologies and the situation of cost curves, it seems that the most efficient solution in certain energy industries, intensive industries that needs high temperature processes, some heavy transportation, maritime, rail transportation, air transportation, aren't viable technically or economically. This is why hydrogen is a viable competitive alternative. Let's acknowledge there's still a gap that we need to act on. Which opportunities do we consider renewable energy offers for the Spanish steel industry? As we were talking about, there are industrial processes that could use hydrogen, such as substituting coke in high furnaces. Teresa and the rest of the speakers have said a lot about this. And I'm sure a lot of expertise is among our listeners. We also can develop value chains of hydrogen economy. We increase demand, the outtakers. No doubt society will demand final and intermediate products that are compatible with decarbonization. There are market niches that are starting to appear. If we can identify them and move quickly, they can create competitive advantage positions in the European industry. And we need to spearhead this process. There's also a challenge here. We must potentialize or drive R&D. We need systems and team goods that use renewable hydrogen that will favor resilience of steel sector companies in a global market, and that has no mercy, honestly, in terms of competition. With other protection tools of the industry, we may add value to all the processes. With research and development, we have a more general overview, and this will allow for a higher renewable energy penetration. Hydrogen as a fuel manages to store energy, and we can use the excedents in production compared to other non-predictable productions in mid to long term will need a storage that is daily. And here, hydrogen is an opportunity to maximize and optimize the use and the park of renewables that can get to 60 gigawatts in terms of new plants of renewables up until 2030. There's also a very relevant dimension here, that has been brought up by Jesus. Here in Mallorca, you can see a good example of this. Hydrogen is a very valuable tool in those isolated energy systems and renewable systems. So here, Spain has good examples to this due to its size, dimension, and partial or total isolation. It has higher difficulty because it cannot really enjoy this kind of scale economy. Manuel, we have 3 minutes here for the general conclusion. Sorry. Okay, the roadmap has a vision here for the development of 4 gigawatts until 2030. Quantitative goals here in other uses of the sectors in terms of transportation where hydrogen may pop up, with all the data that you can see in the deployment of networks and lines of buses that use hydrogen fuel, which prioritizes the roadmap. We believe that the big gains here are substituting gray by green hydrogen. 70% of hydrogen in Spain comes from steel work. This is where we have a big decarbonization opportunity. This is where we should gear our lines. Okay, here, lines of actions. We have regulatory tools or instruments. Many come from Europe. We talked about directives and EIA. Of course, we need to harmonize and update this because hydrogen, as we have said, is in clinical industrial scope. But we need to work on this regulation so that it doesn't become a barrier for deployment. We need to streamline as well our processing in terms of public use, all the regulation of third parties, ability to develop with agility, all the infrastructure associated to the hydrogen value chain. And also a paramount point here is to be able to monetize and prioritize hydrogen that can be used for renewables. And here I remind you, the ministry has published information concerning renewables in the context of a decree that talks about reviewing directives on renewables. And I invite all the participants here for the contributions of this public information. Is a normative project that's going to be developed in the next weeks and months. Also, the roadmap is here in terms of sectorial integration that has to do with hydrogen as an energy vector. We have written down those that have the most important implications for the sector. And here we have cross-cutting instruments. Here, especially considering research and development, we have to drive the learning curve and cost management to be able to fill the gaps. And to finish here, a very brief reference to PRTR, the Recovering Transformation and Resilience Plan. We have 10 leverage policies and about 30 components. There is one specific one, the just and inclusive part 1 pillar
ya tiene este objetivo que coincide plenamente con el de la hoja de ruta y tiene una dotación presupuestaria total de 1.500.
We have a budget of 1.5 billion euros up until 2023. We have 4 pillars of acts here: the innovative and knowledge value chain, which is focused on industrial development of production here. Research and development. Line 2 is clusters of renewable hydrogen, which allows us to join all participants of the same value chain, leveraging the synergies and circular economy. Line 3 here, pioneer singular projects will receive hundreds of very interesting proposals. And line 4, that is focused on the integration of PRTR with the project of which wants to match the lines of the recovery plan and all these waves that have started at the European level. The first wave last summer drove and has highlighted those projects that have an impact in the industry. I thank you so much for the invitation. That's what I wanted to say. And I'll be here for the questions and answers. Thank you very much. Thank you, Manuel, for your presence. You know that we don't have a lot of time in these days. And thank you so much. It's a pleasure.
Nuestro siguiente ponente.
Our next speaker is Martin Pay.
Martin Pay es vicepresidente ejecutivo y director de tecnología.
He's the executive vice president in SAP. Has worked a lot in mining and metals, specialized in research and development, in international sales, manufacture, change management, etc. He has a PhD in metallurgy and material science at the Royal Institute of Technology of Stockholm, Sweden. Responsible for the hybrid projects in iron making technology, where the partners, as you well know, are SAP and Vattenfall. He's president of the Hybrid Council and member of the Royal Swedish Academy of Science since 2017. Martin, the floor is yours. Thank you.
Thank you very much for this kind introduction, Alejandro. Could you share my screen presentation, please? I hope you hear me well.
Te oímos perfectamente.
You hear me?
We can hear you perfectly, yes.
Very good. Thank you. Could you go to the next slide, please? Yes. Thank you very much for inviting me to share our experience so far with the hybrid initiative in Sweden. I will make a quick introduction why we started the hybrid initiative and why SSAB is on the way to transform to a fossil-free steel company. And I show a few milestones, how far we have come so far, and finally our roadmap towards the implementation of this new technology. Next slide, please. Yes, we all know that steel is an extremely important material, especially thinking the task ahead of us to decarbonize the whole society. Steel is going to be absolutely one of the most important materials that we need to produce also in the future. Steel is also very good. We can recycle it on and on again. And it is also a material that is available almost everywhere in the world. However, the steel production technology that is used today produces significant amount of carbon dioxide emission. That's what we, as an industry, really need to find a solution for. Next slide, please. There are quite a number of different analyses. We at SSAB, we did a study back in 2015. We realized that if the steel industry globally should pay its own share, take its own share of reducing emission, the industry needs to cut emissions from the annual CO2 emission of about 2.8 billion tons a year in 2015 to somewhere close to 500 million tons a year in 2050, if the steel production was kept constant. Well, that is not the case, as we know, as shown here in the middle of the chart. The forecast of global steel consumption is going to grow significantly. Luckily, the biggest portion of this growth is going to come from recycled scrap, but still, the iron ore-based steel production, as is shown in the middle of the chart, the light blue bar, is foreseen to continue to grow. That gives us a conclusion that the steel industry needs to develop breakthrough technologies instead of continuing using the currently dominating blast furnace technology to make steel from iron ore. Currently, there are a number of different technologies that the steel industry are developing, and I will show now what our development work has focused on and how far we have come. Next slide, please. SSAB is the largest steel company in Sweden and Finland. Our blast furnaces are very, very efficient, since we did a significant transformation 40 years ago. Together with LKB, we developed the very high quality blast furnace pellets that LKB invested a lot of money in to produce, and SSAB run all 5 blast furnaces we have in Sweden, Finland, with this 100% of such iron ore pellets. So the blast furnaces we are running are very close to what it's theoretically possible with this current technology. But still, SSAB as a single company is still the company that emits most carbon dioxide, both in Sweden and Finland. We stand for 10% of Sweden's total CO2 emission and 7% of Finland's CO2 emission. At the same time, Sweden has also a rather good starting point, since the electricity grid is fully decarbonized. And Sweden has also excess of electricity production capacity. So with the long history of developing the metallurgical industry, and with also tradition of cooperation along the value chain, so we suggested to create the hybrid initiative, which we have been working since 2016. Next slide, please. So what we actually want to do is, if you look at this, is quite simple. We want to use hydrogen to reduce iron ore instead of using coal and coke in the blast furnace process. With that, we get rid of the root cause of CO2 emission, and we will use locally produced electricity instead of importing coal as we do today. Next slide, please. We did, when we started the project, we launched a quite significant R&D program. We involved most relevant universities, research institutes, and we have later on also created the hybrid development AB, which is joint venture company owned a third each by SSAB, Vattenfall, and LKB. And we have then done a very extensive pre-feasibility study. Next slide, please. This chart summarizes the conclusion from our pre-feasibility study, which compares our current production technology using this iron ore pellets-based steel production in northern part of Sweden, compared if we would transform into the hybrid process route shown to the right of this chart, how the main consumption figures and emission will look like. So what we are essentially want to do here is what we want to use this high quality iron ore pellets that LKB makes today. And instead of going through the blast furnace using coal and coke, we want to go through a shaft furnace-based direct reduction process using hydrogen. And hydrogen we want to produce using water electrolysis. We have heard very interesting analysis earlier in this conference. And we here, what we focus on, we're not making a lot of efforts in further improving the electrolyzer technology, but on the other hand, we are, as one part of our development work, we are studying a technology to store hydrogen gas at high pressure. In that way, we can improve the connection with the electricity grid so that we can allow more wind power component in the future. And the sponge iron, which is then produced in a hybrid process, will be melted together with recycled scrap in an electric arc furnace melt shop, and then continue for production of high quality steel products. Our assessment in 2018 was that this technology, we believe technically is viable, and also economically this is attractive, since we believe that the electricity production using renewable sources in the future will further develop. So we will have a lower cost of electricity, and also the electrolyzer cost for hydrogen production will also develop, as we have heard earlier in this conference. And in addition to that, the hydrogen storage technology will further improve the process economy. We believe also that the emission cost of carbon dioxide with a blast furnace-based conventional process will also go up. So that makes the whole business case attractive for us in Sweden and Finland. So we decided to invest in a significant pilot development program where we study the decarbonisation of the pelletizing step, and then with a hybrid direct reduction process, including a hydrogen electrolyzer plant, and then using carbon-free sponge iron in the electric arc furnace. So we have been doing that since 2018, and now I want to show a few milestone moments. Next slide, please. Yes, please go to next. So we made the decision to build the hybrid pilot plant. This was in the groundbreaking ceremony, participated with the Swedish Prime Minister. We started construction in June 2018. Next slide, please. And the plant was finished in summer 2020. Took about 2 years. And in the middle of this, it came the COVID-19 pandemic. So we had some delays, but finally we got this plant into operation. So since then we have run several campaigns, studying different steps of this new technology. Next slide, please. The project has been highlighted in quite a number of different places. European Union President called this project as a lighthouse project for European industry. And at the United Nations Climate Action Meeting in New York in 2019, it was also launched this industrial leadership group for industrial transition by the Swedish Prime Minister and the Indian government. And this hybrid project has been highlighted as one of the most groundbreaking technologies that we're developing. Next slide, please. We earlier this year in June announced that we have successfully run the pilot plant continuously using 100% of fossil-free hydrogen and produced the first batch of sponge iron without any carbon inside. we have come to a point where I believe that the technology works at this pilot plant scale. Next slide, please. And we use part of this spondrine, made the first batch of fossil-free steel plate products, which was delivered to Volvo Group on 18th of August this year. Next slide, please. And then just 2 weeks ago, Volvo Group showed the first vehicle made by this fossil-free steel, which was shown to the public, and the European Commissioner was there, participating in this ceremony. And this is a very interesting vehicle. This is a fully electric truck, can be run autonomously, self-driving, so to say, and can be used in quarries and in mining operations. And this is the first prototype. Our ambition together with the Volvo Group is to continue to make a limited number of such products, and also other products that Volvo want to show from our continued trial deliveries from this hybrid pilot plant in the coming years. But this is a small amount we can make, since it's not a production facility. Next slide, please. And now I want to share what we are going to do next step. Next slide, please. So our plan is to scale this technology. The first step will be construction of a hybrid demonstration plant at one of LKAB's mining sites in northern Sweden, in a city called Gällivare, where we have started the permit process, where we are planning to build a facility producing 1.35 million tons of hybrid spondrite a year, using pellets from LKAB, which also will be produced without using fossil fuels. So it's a lot of work we need to do before that. And Vattenfall will support with supplying fossil-free electricity, including building the electricity grid connections, which also be a very important component for that. And SSAB has started the transformation of the Oxelösund plant, which is located south of Stockholm, where we currently are running 2 blast furnaces, 1 coke oven plant and 1 BOF melt shop. So our plan is to transform the Oxelösund site and build a new electric arc furnace melt shop. So we will take the spondrine from the hybrid demonstration plant and make steel out of that. We will produce heavy plate products in Oxelösund. We will also ship part of the volume to our Borlänge site, where we have strip products, both hot rolled and cold rolled products, and supply to a number of selected customers. In addition to Volvo Group, we have entered into partnerships with Volvo Cars, which is a car company, and also Mercedes-Benz has a very strong commitment to decarbonize. And Forensia is a big company in the automotive industry, and a number of other companies, especially in the building and construction segment, are waiting for our products to come onto the market. And we plan to do these commercial deliveries from 2026. Next slide. Yes, finally, this is a summary of what we have achieved so far and our plan moving forward. As I said, that we started hybrid initiative back in 2016. Right now, we are in the middle of the, we call it the feasibility study phase with pilot plant trials. And the hydrogen storage pilot plant is currently under construction. And our plan is that pilot will be start testing from second quarter of next year, which is connected to the hydrogen production plant, electrolyzer plant at the hybrid pilot plant, just 3 kilometers away. So we are under construction doing that hydrogen storage, and that is one very exciting development in addition to the direct reduction plant. Then following the Oxelösund transformation of SSAB, our plan is to continue the journey. So before 2045, we plan to also shut down the blast furnaces in both our Luleå plant and in our Råa plant in Finland. So before 2045, SSAB aims to become a completely fossil-free steel company together with LKB and Vattenfall. So we are all committed to this very ambitious target. That, I think, finishes my presentation. Thank you for your attention, and I'm happy to discuss in the Q&A session. The next step. Thank you.
Muchas gracias, Martin. Muy interesante. Muy interesante. Y comienzo.
Thank you very much, Martin. It was really interesting. And I'm going to start with you. We have a first question, and they're asking us that, and they're telling it was a really interesting project and a really interesting presentation. And they're asking, what is the exit capacity of the pilot plant, and what have been the partners that have given the technology for the plant reactor? Thank you very much, Martin.
Oh, yes. The pilot plant is dimensioned for 1 ton of sponge iron per hour. And we've been running stably with good, very good quality, safely at that capacity. So we have run a number of campaigns. We're right now in one of the campaigns that we are running. So it's been an exciting result we have achieved so far. We are, in addition to producing this sponge iron, we are also running trials in a 10-ton electric arc furnace nearby at the Metallurgical Institute, Sverim, where we are starting to make steel using this sponge iron. And there, one of the most important aspects we test is to use hydrocarbon, because to make steel, next step, we need to add carbon, and that we have been studying also. So we have worked with quite a lot of technology providers in order for us to build and run these pilot trials. So just for example, part of the hybrid pilot plant, the reduction shaft was supplied by Tenova Hyl, which is a very good cooperation partner. And for the electrolyzer plant, it was supplied by the Norwegian company Nel. And we have a lot of automation, a lot of different components. So I cannot name all of them, but we are very, very thankful for all the collaborations from our partners and suppliers.
Gracias, Martin. La siguiente
Thank you, Martin. Next question. And I think that we have answered this question at the end of the presentation, because I think we went too quickly. But anyway, it's for Manuel. And I think that we might explain that more in detail. Well, this question is about the benefits or the aids that we have given, because we need some benefits or some aids for this transformation, right? So what are these instruments? What are these tools? And I think it should be really relevant to underline what are the aids that we're going to get, and their amounts, of course. Yes, so the 9th component of hydrogen, of the PERTE, was part of a plan in which we're working, which is, of course, related to renewable energies and renewable hydrogen. And we also have all of the different technologies for to achieve this energy transition. And as I said during my presentation, we will set some bases and some legal frameworks that we will set together with IDAE, which is our government and energy agency that we have. And thanks to the latter, we will be able to direct the European funds and the funds in general, so that we can direct them efficiently. And we will also divide them by according to the needs of the different regions in Spain. and then we will share the different funds and competences to the different Spanish regions. So it's true that there was a more ongoing component. This is, we have to know what self-consumption is. We are launching now some plans, and we have also these hydrogen plan. We don't have a previous experience with that, so we need maybe more time to really know how we're going to set up the hydrogen grid and the configuration of the hydrogen. But as soon as we know how we're going to implement this plan, we're going to let you know, and it's going to be published and made public. So once we know how many funds can be allocated, we will let these know. And of course, we will have a competition, and we will prioritize these plans that, thanks to their maturity or know-how or knowledge, are better. I cannot commit now to say exactly when these plans are going to be launched or the amount of money that is going to be directed, but because you know now that we have a crisis when it comes to the energy prices, right? So I cannot say anything now. Thank you, Manuel. Next question is for Teresa. She was asked that she was talking about the carbon sequestration and the capture. So could you give us a description of the current state of the facilities that we have now of your company and the temporary and realistic deployment that we're going to do so that these technologies can help this sector? Thank you very much, Alejandro. Thank you very much for asking this question. As for capture and carbon sequestration, you know that the CO2 we consume maybe in our Coca-Colas, our the drinks, or whatever, any technologies are captured. So it's a technique that exists for a long time. However, the new challenge that we had ahead was to get a high percentage of carbon capture. It's true that I was told not to talk much about my company, but you're going to allow me to boast about my company in a way, because we've been implementing this company since 2015. And you know that the first facility that we had was in one of the hydrogen plants that we have within the group. And we saw that there were big plans in Europe in which we are participating. For example, we have the Rotterdam harbor, and 3 public companies and 4 private companies made an agreement to try to capture the CO2 in the region. It's a cross-border program that we have set between different countries, and I think that this could be the perfect example of success of this partnership. But I completely agree with what Manuel was saying before. Hydrogen, the hydrogen that we must bet on is a renewable hydrogen. And technology can open up many doors for us. We can also discuss about synthetic fuels, but what we have been discussing during this conference has mainly been the renewable hydrogen. And this is the most important thing. Technology, well, we don't have a winner or winning technology right now at this precise moment, but we will have one. In our case, we have had some partnerships with other companies, and it's true that we tend to focus more on alkaline products. But I think that the most important thing about this is that we are facing a fantastic situation in which we will be able to develop many things, and collaboration is more than necessary, and technologies are moving forward really quickly. And in this new reality, we have to make a lot of regulatory efforts, because everything is changing so fast, as Manuel was saying, and we need to keep up the pace. Because during the last few months, for example, we have had many new projects. But anyway, part of the challenge that we have ahead.
Gracias, Teresa. Ahí tenemos que trabajar todos juntos.
The connection of the speaker is not good, and we cannot interpret. Yes, we have made trials at an industrial level for hydrogen. So the question is, do you think that there is the need to develop new maybe coatings for the steels or new solutions so that we can ensure the transport of hydrogen with the current infrastructures? Thank you very much. Thank you very much, Alejandro, and thank you to the person that asked that question. Well, first of all, here we should make a difference, and we should know if you're talking here about infrastructures that will transport hydrogen, 100% hydrogen. So we would be talking about sensitive infrastructures, or if you're talking about something else. Now, if they are sensitive and 100% dedicated hydrogen transport infrastructures, we would have a new design infrastructure. So we would have new green fields of hydrogens, new pipelines. And in this case, the reference codes that we use for these kind of infrastructures is the ASME B3212, which is the code that we use, the reference code that we use, and this includes all of the deployment of the materials designed that's related to the pipeline infrastructures and accessories also for 100% hydrogen transport. In this sense, from a material point of view, it is true that we have included a number of reference codes, some codes that for us are common. It's true that we use a huge amount of materials, for example, in the case of natural gas, that are completely compatible and usable for designing gas infrastructure. For example, carbon steel with ASTM codes and API codes. We always work, and we have always designed the infrastructures with API 5L code, and the equivalent of the European standard is carbon steel. So, of course, we have to analyze of the operation status of these infrastructures to check what the width of the materials are, and to detect the effects of likely embrittlement that could hinder the good status of the hydrogen and the molecules of steel. But in principle, the materials are similar, the codes are similar. So in principle, and we're doing this, by the way, we could design the infrastructures now with the reference that we have. Another different thing is how to develop the infrastructures according to the regulation. And as Manuel was saying, the grids of infrastructures, because here we have to take into account the regulation, because we should consider whether or not it's a utility. Then we should also calculate the width of the width of the infrastructures. If the pipelines go through densely populated areas. Now, as for the pre-existing infrastructures, we will do a case-by-case study here, because we, with the ASME 318 and the European reference, and according to the Spanish regulation, we will reconvert natural gas infrastructure into a 100% hydrogen infrastructure. And we have to calculate the width of the pipelines. And you must calculate the pressure, the operating pressure when transporting natural gas, and the operating pressure if you're going to transport hydrogen. In most of the cases, we have to reduce the operating pressure of the gas-related pipelines so that we can transport hydrogen. And here I'd like to make a distinction because we have a lot of literature and we have some confusion because what we transport through those pipelines is just energy, power, and this is calculated in certain ways. When you're speaking about hydrogen, you must talk about megawatts per hour. If you're going to transport hydrogen in molecules, you're transporting kilos or tons per hour. And in this sense, I'm talking about logistics. If a pipeline has a capacity of 80 bars and it can transport 2 million of cubic meters per hour with 80 bars of pressure, like the situation in Spain, and you have to reconvert it to hydrogen so that we can not operate with 80 bars, but with 60 bars, so that we can adapt this to the design regulation. That means that you're going to transport less energy because you have to reduce the pressure because you're using this kind of infrastructure. But if we want to focus on the volume of power, we have to increase the mass that's transported. As for the new materials and designs, we currently have alternatives to the carbon steel, for example. Usually we use a lot of inox steel or stainless steel. It is really common, for example, to use stainless steel 3,4 or 316 stainless steel for all the piping associated to an electrolyzer. And if you want to design an infrastructure of 300 kilometers, if you have just 20 inches of stainless steel, it's complicated and it's really expensive material-wise and execution-wise. It's really complicated. This is why I'm saying that carbon steel is the perfect solution. Of course, if we optimize the equipment, and we can use it in different for different fittings, valves, pipelines, etc. They're perfect for hydrogen. They're the perfect fit if, of course, we apply the safety criteria that are more than essential. Can we use other materials? Yes, we can use reinforced systems, composite systems, and we can also use inhibitors within the pipeline to avoid some embrittlement, accelerated embrittlement. And the maintenance times of the infrastructures change. We actually include intelligent or smart pistons, and we have to ensure the integrity, the inner and outer integrity of the structures. And you have to adapt the materials that we have. But all in all, I would say that there is not a lot of difference between hydrogen structures and natural gas infrastructures. They're not so different. We have experience in doing with complex liquid like liquefied natural gas, and this is our day-to-day work. Thank you very much, Jesus, for this explanation and for all of these technical details. So the question and answer session is over. This roundtable is now over too. I hope it has been fruitful and interesting for all of the participants. And now, without further ado, to end this conference, we give the floor to Santiago Oliveira. You have the floor. Well, I've been told that I have to finish really early, so do not worry. After all of the interesting presentations, I'd like to thank the different speakers for their presentations. Actually, it was really easy for me to thank you because, first of all, steel will play an important role in this new hydrogen-based economy, as we have seen. But as an engineer, I like statistics. I actually counted the different words that have been appearing in the presentation because they are all intertwined and interrelated, and you will understand how they summarize these conference. First of all, it's decarbonisation. That goes without saying. It was the most obvious one. But the most repetitive, repeated word was all. All, because we have to have the government, we have to have the providers, we have to have the consumers. All of us must be there. Innovation is also an important word. You have all said the word innovation several times. Two other words that have been repeated have been ambition, situation, moment, and opportunity. So we cannot leave this opportunity. We cannot let this opportunity go. Spain has a lot of renewable energies. We have a high capacity of creation and production. And another repeated word, and very much related to the other one, to accelerate. It's the moment to accelerate innovation, to support acceleration, and we have to support it. And this is the right moment for us. We have to gain momentum. Another word that has been pronounced by all of you has been legal. The legal framework, the regulation, the need to set some criteria that allow to come to an agreement between the different parties. If you have worked with the different partners, you know that we all have to come to an agreement, and we have to set a good legal framework, because without this, we will not develop or enhance the infrastructures. And another word that has been heard was cost. The word cost is, together with innovation, all, and ambition, is an essential word. Not only must we have a legal framework, but we have to set the cost for OPEX and CAPEX, because we have to relate the cost to those lines. And last but not least, a word that has not been present in all of the presentation, but has been there in two, is, at the end of the day, we have to sell. All of us, especially when talking about the consumers, we have to produce something that can be sold, that can be commercialized. And this is why we have to set a legal framework to create a market, so that we can underline the effort, the innovation, the decarbonization, and so on and so forth. And I think that with this, the summary that I have suggested is all that I have, and it's more than enough. And without further ado, I leave the floor to Andres. Thank you very much, Santiago. Thank you very much to all of you for participating. Thank you very much for the speakers, because you brighten us with your knowledge. Thank you very much for giving us your time, because we know that we all need time, because it's one of the more scarce variables, right? So thank you very much once again to having participated, and I promise that we will gather here again in the future. And one of the good things that this pandemic has brought to us was the punctuality. We are now in time, so we can go back to our duties, and I wish all of you a pleasant weekend. So thank you very much once again, and see you soon.